We'll finish this second arguments lecture by going through two examples that are illustrative of our newly developed counterexample method. At various points, I'll suggest that you stop the video, try to complete the next step in the process, and then start the video and compare what you did to what I did. So suppose we start with an argument like this. Wildebeest are cattle because all cattle are mammals and all GNU are mammals. The first thing that we're going to want to do is to put this argument into standard form. Identify the premises, the conclusion, put the premises first, the conclusion last, make all the content phrases the same in every instance of their use throughout the argument, and so on. So you can stop the video, try and do that, and start the video and see how your answer compared to mine. So I took this argument, the argument, and I came up with a standard form version of the argument that looks like this. We have a premise indicator because, and that premise indicator is always immediately before premises and usually after a conclusion. And so that last sentence looks like the conclusion to me. So I moved it to the end. Then I made all the terminology consistent. It turns out wildebeest are just another name for GNUs, and so I decided to use GNUs, in part because it's shorter. My first premise then is all cattle are mammals. One separate declarative statement that indicates this particular fact, the first premise. My second premise is a second declarative statement that says all GNU are mammals. Then I have a conclusion, a third declarative statement that says all GNU are cattle. Now that I've got this rephrased argument, the next thing I want to do is to identify the logical form words in the rephrased argument and substitute in capitalized letters for the content phrases that remain. And so you can stop the video, try and do that for yourself, then start the video and compare what you did to what I did. So let's see what I did. When I looked at this argument, I said, okay, I'm going to have to identify the logical form words. And in order to do that, I have to know which logical form words are associated with categorical arguments, that is, arguments that relate classes of things to one another, and propositional arguments, that is, arguments that relate statements to one another in terms of their truth value. So the common logical form words for categorical logic include all, no, are, and are not. The logical form words for propositional logic include if then, and, either or, and not. So I realize that this is a categorical argument, and now I want to highlight those logical form words in the argument. And that will give me this. Once I've identified the logical form words, I'm going to keep those logical form words there, and I'm going to substitute in capitalized letters in a systematic way for every instance of a content phrase that occurs in the argument. If you haven't already done that, stop the video and do that, and then start the video and see how you did. Here's what I got. I substituted C for cattle in the first premise and in the conclusion, M for mammals in the first and second premise, and G for GNU in the second premise and the conclusion, and that gave me my rendition of the logical form of the argument. Now I'm going to want to substitute in new content. I want to do it in a way that makes it clear to anybody who happens to look at this new version of the argument that its premises are definitely true and its conclusion is definitely false, so that I can make that inference, or anyone who picks this argument up can make that inference that every argument, including my original argument, is an invalid argument because the truth of the premises will not guarantee the truth of the conclusion. So again, you want to stop the video. Try and come up with a substitution instance that makes those premises definitely true, that conclusion definitely false, then start the video and see if what you did compares to what I did. So here's what I got. I created a substitution instance using mice, mammals, and humans, so that those first two premises, all mice are mammals and all humans are mammals, they're easily and obviously recognized as true statements. The conclusion is equally easy and obviously recognized, but recognized as something that has to be false. So now I've created a version of the argument. It has the same underlying structural relationships, but the premises have to be true and the conclusion has to be false, so that I know that all versions of the argument, no matter what their content is, will be invalid arguments now that I've demonstrated that definitively. Let's take a look at an example of an argument that's a propositional argument and see how our counterexample method works in that case. Suppose we have the following argument. Either my professor is rated on ratemyprofessor.com or my professor is rated on professorperformance.com. My professor is rated on ratemyprofessor.com, therefore my professor is rated on professorperformance.com. Now, besides the horrible alliteration, the first thing that I want to do when I evaluate this argument is to put the argument into standard form. So again, you might want to stop the video, see if you can do that, then start the video and compare what you did to what I did. So I put the argument into the following standard form. We have a conclusion indicator, therefore. So I put that first premise, either my professor is rated on ratemyprofessor.com or my professor is rated on professorperformance.com first. The second premise follows that, and the conclusion ends the argument. The next step is to identify the logical form words in the argument. So again, you might want to stop the video, see if you can do that, then start the video and compare what you did to what I did. So here's what I got when I identified the logical form words using that list of propositional logical form words. Either my professor is rated on ratemyprofessor.com or my professor is rated on professorperformance.com. So now I see that this is the disjunctive syllogism. That first premise is a disjunction. So I'll keep those logical form words and then I'll substitute in capitalized letters for the content phrases, in this case for individual statements within the argument itself. So again, you might want to stop the video, try and do this yourself, then start the video and see how you did in comparison to what I did. Once I have those logical form words identified in my standard form version of the argument, I then identified the content phrases, in this case the individual statements that are related to each other in terms of their truth values in my propositional argument. I'll highlight those so that I know where each of those propositional statements occurs in the context of the argument, and then I'll go ahead and substitute in capitalized letters for each instance of each individual simple statement. And this will give me the representation of the logical form as so. Now, my final step is to introduce content that makes the premises clearly and obviously true and the conclusion clearly and obviously false. Again, you might want to stop the video, try and do this yourself, then start it and compare what you did to what I did. So I started with this representation of the logical form and I introduced some content in the form of declarative statements or the individual declarative statements in the context of the argument. And what I came up with is either dogs are mammals or dogs are reptiles. Dogs are mammals, therefore dogs are reptiles. Clearly my first two premises are true. Then my conclusion is obviously false. And so I've created a successful counterexample. I've shown how the logical structure of this argument is such that it's possible for the premises to be true and the conclusion to be false. And I've done so in a way that the content helps us to see that flaw in the argument's underlying logical structure.